Greetings, programs. Welcome back to Stegosaurus Studios. It has been a very long time since the last two episodes. The last two episodes were right before and right after Maker Faire. Maker Faire was at the end of September, and it's now midway through January. So, holy cats, it's been a long time. Must be a real slacker. So, there's lots of reasons, which I'm not going to go into. But I will say this, I kind of wanted this episode to be all about sound, all the sound stuff on the robot. And there's one aspect of the sound stuff that is hard, and at least hard for me. And so that I kept putting off doing a video because I kept thinking I was going to get that part of it done, and I didn't. So today we'll talk some about sound, but then there'll be other, it's pretty much just going to be a status update. So again, apologies that it's been such a long period of time. So let's actually start by relocating to the garage, which one of our local builders called it the second shop. My wife now says I have 4 shops scattered around the house. So let's relocate, okay? Okay, we are now out here in the garage. Dummy's lost his head again. Let's do the status update. So in the last one or two episodes, I guess in the last episode, I talked about splitting the power so that I could turn off the drive system, park him, but still have other things operating. And it's going to be hard to see, but essentially there's 2 Anderson power pole blocks, one there and one there. You can see all those Anderson connections. It used to be 1 big power block, so now it's 2. So I have all the drive stuff on the one that's on the right and everything else that's on the left, and that allows me to do what I want to do, which is keep things separated. So I also put in a little switch right underneath the seat right there. I wanted to put that switch in, so that switch turns on the power to the. So there's a transformer or step down buck converter, whatever you want to call it, that goes from 12 volts, because we've got 12 volt batteries here, down to 7, and at 7 volts then goes to the power supply side of the Maestros that then runs all the servos. So the servos I'm using run on 7 volts. And one thing that I like to do is be able to turn the system on, let the Kyber run through its startup sequence, and then turn on power, because sometimes you get some funky servo operation if the Kyber, if your control is still trying to boot up. So anyway, all those wiring changes are done. My wiring looks like crap. It used to look good, and then the more things I had to change and add, it's looking worse. And then we'll talk about it in a bit. There's more wiring changes coming, and hopefully in that process maybe I'll clean things up a little bit. So one other thing I talked about in the last episode was wanting to be able to see the voltage of the batteries on the speeder on the transmitter. So here we have my transmitter, and there you can see it's 12.56 volts. There's FrSky, the radio maker. They make this little harness that plugs into the receiver, and then you can connect one of the wires. It happens to be the blue wire. You can just connect that to the positive on the battery, and it will then display. So you don't need any extra sensor. It comes right out of the box with the capability of doing that. So now I have that on display there. The last thing I talked about in the last episode was the RF interference that I was getting. So you'll actually see I've got this wire here with this braid over the top of it. In retrospect, that was not a good idea. I did an event at the Computer History Museum in Mountain View, and so right underneath where that wire is, with the glowing red and the blinking blue, that's the Kyber, and that that shielded braid that you see was pushed down on top of the ESP. So in essence, I blew up the ESP32 on the Kyber. Luckily, I had a bag of 3 of the exact same ESP32s sitting on my desk. So I worked with Neil to flash one of those and resurrected everything. I was worried that I blew up the whole Kyber board, but I didn't. So it was just the ESP32. So it is operating now. So braid, not a good idea. Malcolm and I actually are going to get together. We're just waiting for some cable. We bought some actual shielded cable, some 3-conductor shielded cable, and then we're going to get together and make cables. So we're going to do the crimping of the pins and insert them in the housings and everything. So I've got at least 4 cables that I want to make, and then he also wants to make some for his new Droid DD. He wants to replace some of the cables that he has with shielded cables. So we're just going to get together and do it together. So that's coming. Okay, so let's talk sound. I had no sound at Maker Faire. I didn't even have, I had the amplifier and some of the other components mounted on the frame. Now I have sound. It's a little noisy, but in a convention, you can't hear the hiss at all. Here in the quiet garage, I can hear it. But so anyway, and it's going to be super hard to see, so I'm just going to talk about what's on there. So the Kyber has a DF player. So there's a line that runs from that DF player to a 4-channel mixer. And then that mixer then goes to a ground loop isolator, which then goes to the amplifier. There are 2 other inputs to the mixer, and you can see here you can see it says BT, that's Bluetooth. So that's a power switch to turn on a Bluetooth receiver. So that will allow me to play sounds from my phone, but I don't want that to be on all the time. It's just for certain cases, maybe I might want to turn that on. So Bluetooth receiver. And there is a third thing that is going to be hooked up, and that is, which I will talk about at the close of this episode. It's going to be, well, if it works correctly, it's going to be an audio out from an ESP32 audio development board. And again, I will talk about what the plan is for that. So 3 things into the mixer, and then out of the mixer goes to the sound system. So let's see if I'm coordinated enough to do this. So I mentioned Kyber. If you're not familiar with Kyber, I'm running the Kyber hardware, which is installed in there, and I'm also running the Kyber Pad software. So Kyber Pad works on, I don't know, a bunch of different radios. This happens to be a FrSky X20 Pro, but so you can see there's rows of buttons there that have, and in this case, there are Star Wars songs, right? So if I wanted to play, let's say, it's just hard to do, so the Cantina, and that's how that works. So Kyber Pad has, and it has this. The Kyber Pad has. Got to use the right one. So 2 screens. So you see those buttons changed. Now it says "Life is a Highway." Turn the page. Minute back in black. Now back to the Star Wars sounds. And then eventually there is an update coming on Kyber Pad to have 3 screens, and so I actually have this hooked up already to a 3-position switch, but only 2 of the screens are operating. So anyway, sound system works. Oh, and I forgot, there's the speakers. So I made these enclosures, wooden enclosures out of very thin plywood. I was limited on space. I couldn't make these honestly as deep as they really should have been. So the bass response is pretty crappy. And I couldn't really make them any deeper. And so I'll just have to live with it. I was on a bike ride this morning and I was wondering whether there was space for a subwoofer on this. I don't know. That's now that I'm sitting here in front of this thing, I'm not sure a subwoofer is gonna happen. But anyway, got the speaker enclosures made, got the speakers mounted. So sound system is all working. So the last thing to talk about out here, as far as progress, is on the front end. This thing right here. So I've 3D printed this tray. It's got terminal strip mounted on it. It has another buck converter. This one set to 5 volts. So the one for the other one that I have is set to 7 because I have the servos I use run on 7 volts. But the ESP32 board, as well as more than likely the LEDs, are going to run off of 5 volts, and so that's a 5 volt. But the real reason for putting this together, at least now, is this. This is a bubble machine. So I got, and I mentioned this in the last episode, Jaime was very generous, gracious, and gave me this wand that I then took apart and took all the guts out of. And assuming that I have this working correctly, there you go. So it's hard to see against the white wall there, but it is actually blowing bubbles. So the bubble machine works, and I have that hooked up to down here to this switch, which is a momentary switch. So for right now, I just have it. I'm just holding the switch up for as long as I want the bubbles to blow. But I could write a Maestro script, use the same button just to trigger the script, and then run it for a timer. So I haven't decided, but for right now, I'm just holding it. So this, as you can see, this is the little pot for the fluid, and then the motor, and then the bubbles come out here. It drips a little bit, so I 3D printed this tray, which is actually removable, assuming I can remove it. So you can take it off, empty it, clean it, whatever. Yeah, that's it. Okay, so that's the end of the demo of the status. We're gonna relocate back to the shop, and I'm gonna talk a little bit more about this ESP32 project for the sound, and then I will close the episode. So see you in a moment. All right, we are back here in the shop. So let's talk this last little bit about this ESP32 audio development board. Basically, I don't remember. I honestly can't remember if I've talked about this in the last 2 episodes or not. I want to make a sound for a speeder bike. So if you watch, any of the shows or whatever that have speeders on them, they make a sound that changes with the acceleration, right? So I want a sound that does that. I want a sound that when I push the throttle forward, it changes in pitch and frequency or whatever. And so I actually started off just with a query on, I think it was using DuckDuckGo's AI, just asking what could be done. And it pointed me to a program called Pure Data, which is a FM synth, frequency modulator synth. And played around with that on my Mac, and actually, within a pretty short period of time, had something that I felt was like a really good start. And so theoretically, according to the AI, you should be able to compile a Pure Data patch and load it onto an ESP32. So that's the goal, is to compile this patch, get it on the ESP32, and then hook up the Maestro to the ESP. The Maestro has an output that's configurable for PWM out. And so send that PWM signal to the ESP, read it on the ESP, and then turn that into an accelerating sound. So, and I've had a lack of success so far, and that I've been actually kind of poking at this for quite a bit, and but I found some stuff this morning that hopefully is going to get me in the right direction. So, hopefully, next episode I'll maybe have that figured out, wired up, testing. It may not be the final sound, it may not be the final patch. And when I do this future episode, I'll talk about what a patch is and what FM synth is and that sort of stuff. So, so that's it for this episode. That's the update. Actually, just briefly, really quickly before I close. So, do the sound. Assuming I get that done, do the rewiring associated to get the ESP mounted and wired, and then it's on to motion of the hand and the head, and then future after that. Once those two things are figured out, then it's designing and putting body panels on. So I can sort of see the light at the end of the tunnel on this, maybe. I actually have some stuff already for the wrist, but we're not going to get into that today. So anyway, thanks for tuning in. Again, my apologies that it has been such a long time since my last episode. So take care.